Hey gang, so this is the bottom of page 16, the integral properties. Okay, these just kind of make sense. We've been doing the antiderivative, and we're doing indefinite integrals where we don't have those set boundaries. So this just says, if you do the integral of f of x plus g of x, think of it like this, like your f of x plus g of x dx. The integral property says that you can take f of x, integrate that one, and then integrate this one, and you get the same thing. So the integral of f of x dx plus the integral of g of x dx. And that kind of makes sense. Now, this goes for addition or subtraction, so I'm just going to put my plus or minus underneath there. All right? That is really the only one that we're going to use. So that's the only one I really kind of want to go over. And so what I'm going to do is go over here and let's take some of these examples and let's actually look at them. So I'm going to call this example 1. I'm going to come over here and put example 1. So this says the integral, we're going to integrate f of x and we want to integrate f of x. So we want to do 5x squared plus 4x to the negative third dx. What that says is I can break this apart. I know how to integrate this. I know how to integrate that. I'm just going to use that. Now, let's go back and let's review our rules of this. I was going to try and find it on here. I think I have it written somewhere. Yes, I just wanted to have it handy. So we are going to be using this right here. I'm going to highlight this. That when you integrate, this is the rule that we did on the last video. Okay, so we're going to be using that rule right there over and over. So I'm going to take a piece of paper and I'm going to say when you integrate ax to the n dx, you get a over n plus 1 times x to the n plus 1 plus c. And there's lots of different ways that we can find that c out, which we learned in our last video. Okay, so using this, I'm going to put this right here. We're going to use that to solve this. Okay, so on the first one, I'm going to do the integral of 5x squared plus the integral of 4x to the negative 3 dx. All right, I'm going to integrate this first one. So on the first one, a is 5 and n is 2. So it's going to be, let's see, a is going to be 5 over 2 plus 1 times x to the 2 plus 1. So this is going to give me 5/3 x to the third. And I'm going to check it. So let me move that up some. When I integrate that, the 3 would come down, the 3's would cancel. This would be 5x squared. And then I'm going to integrate this one. So on this one, I'll do this one in red. This one, my a is 4 and my n is negative 3. So 4 over negative 3 plus 1 times x to the negative 3 plus 1. So this one would be 4 over negative 2, right? Negative 2. So 4 divided by negative 2 would be negative 2. X, negative 3 plus 1 would be negative 2. Okay, I'm going to check that. Negative 2 times negative 2 would be a positive 4. Reduce that by 1 would be negative 3. So it did integrate. So here's what I need to do. I need to take 5 over 3 x to the third minus 2 x to the negative 2. That's the integral, but I need to remember when I integrate those, I have to say there could have been a constant over there. So what is the integral? I'm going to put it up here. It would be 5 over 3, the antiderivative, x to the third, minus 2x to the negative 2 plus c. I don't know any points on this, so I can't really figure out the c. I'm just going to leave it like that. Okay, now I'm going to do the second one. Yep, that was that one. Okay, I'm going to run out of room doing these, but I'll do what I can here. I think I just did a couple of these when I worked them the first time. So when I integrate this one, I'm going to actually take that 7 and put it under each one. So I need to find the integral of x to the 5th over 7 dx. Let's do plus the integral of negative x over 7 dx. All right, so as we work this one, I'm going to do the first one. I'm going to say that my a is 1 over 7 and my n on this one is 5. On this one, I'm going to say that my a is negative 1 over 7 and my n on this one is 1. All right, so this one, I'm going to do a, so 1 over 7 over n plus 1 times x to the n plus 1. All right, well, 1 over 7 over 6 is going to be 1 over 42 x to the 6. Does that make sense? When I integrate, when I take the derivative, 6 times 1 over 42 would be 1 over 7, which is what I got here on this one. And then 6 minus 1 would give me 5. So the derivative of this would be that. On this one, I'm going to have negative 1 over 7 over, let's see, we'll have 1 plus 1, x to the 1, and then plus 1. So this one would be negative 1 over 7 over 2. So that's a whole lot like negative 1 over 14 x squared. If I took the derivative, 2 times this would be negative 1 over 7 x to the first power, which is what I got. So this one, when I integrate, I would get 1 over 42 x to the 6 minus 1 over 14 x squared. I might want to write that as x to the 6 over 42 minus x squared over 14. So I'm going to come up here and I'm going to say x squared over 42 minus, oh, I'm sorry, not x squared, x to the 6th. X squared over 14. And because I'm integrating, there's some constant that I could have discovered on that. All right, so you get the idea on those. If you want to work these other ones, you certainly can. The one down here at the bottom where you're multiplying, you're going to have to distribute and get this into a form where it's individual things being added or subtracted together. I may go at the end of this video, or I may in class give you those, or maybe this one right here would be a really good check for understanding. All right, so now let's go over to, let me put this here, example 29, and then example 28 looks like that's going to be a check for understanding. So I haven't put it on there yet. I'll put it on there here in just a little bit. All right. All right, so this one we're going to consider the function defined by f of x equals, oh, no, that's a different one. We're doing, oh, that was that one. Oh, I changed my notes. All right, so here we go. Find the integral x to the 4th minus 3 over x to the 4th dx. Well, I'm going to change this, and I'm going to say, let's break this up. X to the 4th over x to the 4 dx plus the integral negative 3 over x to the 4th dx. Okay, I'm going to give you just a minute to kind of work this. I am going to simplify this. X to the 4th over x to the 4th. That is just going to be the integral of 1 dx plus the integral of negative 3 x to the negative 4 dx. I'm going to simplify it like that. Oh, my cat's coming. Please don't jump up here, kitty cat. All right, so on this one, I would want to label what my a is and what my n is. And so when I look at this one, I'm like, well, this is kind of like 1x to the 0. It's like it's not even there. So my a value is 1, and my n would be 0. So remember, we're using our rule here. A is 1 over 0 plus 1 x to the n plus 1. Well, 1 over 1 would be 1. 0 plus 1 would be 1. So this would be x to the 1. This is really just x. If you integrate x, you're just going to get a 1. This other one over here, my a is going to be negative 3. My n is going to be negative 4. Let me give you a second. Here's your rule you're using. So negative 3 over negative 4 plus 1 times x to the negative 4 plus 1. Negative 3 over negative 3 gives me 1. X, negative 4 plus 1 would be negative 3. If I were to integrate that, that'd be negative 3. Take the derivative. I keep saying integrate. I meant take the derivative. Negative 3 times 1 would be negative 3. Reduce that by 1 would be x to negative 4. Okay, so we're doing good there. So here's what I ended up with. I had x, and then I ended up with plus x to the negative 3. And then I want to remember that there is a c. So the original function f of x was this right here. All right, our check for understanding. You've got a lot of examples on this. You're going to upload your work on this for me. I think that's going to be the easiest way to do that. You're going to find f of x, the integral of f of x, so you're going to find the antiderivative here. Then you're going to find the antiderivative of g of x, and then you're going to multiply these two together, and then you're going to find the integral of that one. All right? So I should see 3 steps. We'll call this step 1, or part 1, part 2, and part 3. I'm not sure exactly what it's going to look like, but I know you're going to upload your work on that. All right. I do have a beware on here. The rule you learned in this section works for the sums and the differences, but does not work for the product of quotients. Okay, so that's why on this you have to simplify it out so that you have the sum or difference of a whole lot of terms. Of whatever polynomial you have, you can't have quotients. You have to simplify those so that you don't have the quotient. So there's plenty of room right here. I feel like you can work those. And I feel like that is good for antiderivatives.